Hi, this is Dr. Bharadwaj. Today we will discuss on one of the important topics, that is enumerate nominal, ordinal, interval and ratio measurements. So in this topic what we are going to discuss is, first we will see simple definition. Then we will go for each scale. There are 4 scales, right? One is nominal, second one is ordinal, third is interval, fourth is ratio. We will go into each scale. The important thing we are going to do here is, for every scale we are going to see in-depth medical example. Unless you concentrate on that medical example, you will not understand what exactly happening here. And finally there will be a simple table to remember it. What are the characters of nominal, ordinal, interval, ratio? What are the characters? What characters each of them have will be displayed in a simple table. You can see the topic is enumerate the nominal, ordinal, interval, ratio with medical examples. First one is, there are 4 scales. One is nominal scale, ordinal scale, interval scale, ratio, levels or scales of measurement of data. Based on the 5 characters, there are 5 characters on which each data set can be grouped into a particular scale. What are those characters? First one is whether it is labeled or not, whether it can be ordered or not, whether the data within a data set, can we find the difference or not, can we find the meaningful ratio between the two values within a data set, or whether the data set has a true zero or not. Based on these 5 characters we will decide the data to measure on this one of the scales. Once you classify on one of the scales, what mathematical operations you can perform? One is arithmetic operations. What are arithmetic operations? Addition, subtraction, multiplication and division comes under arithmetic operations. And what are the common statistical operations? Mean, median, mode. These are the simple ones, but there are all many complex statistical analysis that can be done in this, but I have given simple examples by taking mean, median and mode. Now let's go to each scale. First one is nominal scale. What is nominal scale? It is a qualitative or categorical scale. Only categories or qualities of the data set can be seen here. Whether this data can be grouped or not without any order. You have a data, this can be grouped into different groups and there is no particular order. Such type of data is measured in nominal scale. Okay, you can see the characters. Can it be labeled? Yes, it can be labeled. Can it be ordered? It cannot be ordered. Can you find the difference between two values within the data set? No. Can you calculate the ratio? No. Does the data set have a true zero? No. If these characters are there, then it is nominal scale. And coming to arithmetic operations, what arithmetic operations can you do on it? You cannot do addition, you cannot do subtraction, you cannot do multiplication, you cannot do division. No arithmetic operation can be performed in nominal scale. In statistics, you cannot calculate mean, you cannot calculate median, and you can calculate only one thing, that is mode. Okay, with example we will see in depth. Now let's go to a medical example so that you will understand this in depth. First, consider a study where 15 patients walk in, okay, into a general physician's clinic and evaluated for metabolic syndrome. This is a study actually done by Sanofi Aventis, where I was a part of it. This is a cross-sectional study where the physician is sitting in a general setup in an outpatient clinic. Physician is sitting in his clinic and we will take first 15 patients and check whether what problems he have related to metabolic syndrome. This is the data set. Okay, this is the data of the 15 patients. This is the first patient is hypertensive, second patient is obese, third patient is again diabetes, third patient have obesity, fourth patient has obesity again, hypertension. So if you measure, these are 15 patients, 1 2 3 4 5 6 7 8 9 10. This is the 15th patient. This is the data set of 15 patients. Okay, consider this as a data set. What are all the characters you can do? Can this be labeled? Yeah, yes, this can be labeled. How this can be labeled? You take these 15 patients and you can categorize the patients into 3. One is obesity patients can be categorized separately, diabetic patients can be categorized separately, hypertension patients can be classified separately. You can give label to the patient, you can give a name to the patient. This is hypertensive, this is diabetic, this is obese. You can just label the patient. If that is possible, labeling is yes. We will see whether it can be ordered. So can you keep these patients in an order? Is diabetics comes first, or obesity first comes first, or hypertension comes first? There is no specific order, right? You can place it anywhere. So that's the reason ordering is not possible. Can you find the difference? If you can, you take a diabetes patient and non and hypertensive patient, can you subtract each other? No, you cannot do. That's the reason it cannot be differentiated. There is no difference. Difference is no. And coming to the ratio, can you divide hypertensive patient with the diabetic patient? No. So ratio is also not possible. Does it have true zero? There is, it is not a numeric value, so it doesn't have any true zero as well. What kind of mathematical operations you can perform on it? Can you add diabetic patient with hypertensive patient? No. Can you subtract the diabetes patient with hypertension? No. Can you multiply two patients, two values within the data set? No. Can you divide one patient with another? No. That's the reason no arithmetic operation is possible here. Then we will go to statistical operations. Can you find the mean? Can you add all the patients and divide it by number of patients? No, that is not possible. So you cannot find the mean. Can you find the median? If you want to find the middle number, first you have to arrange the data set in an order. Then you have to take the middle value. You cannot order this patients. That's the reason you cannot find mean as well. Can you find mode? Yes. What is mode? The value which is frequently repeated. In this set, you can see diabetes, obesity, hypertension. In this set, you can see these are the values. There are the obesity, there are 7 patients with obesity, there are 4 patients with diabetes, 4 patients with hypertension. Then what is the mode which is frequently repeated? Which is frequently repeated? Obesity is the mode for that data set. In nominal scale, only thing you can calculate mathematically or within mathematics statistically is mode. Only mode you can calculate for nominal data. Let's go to ordinal data. Next, go to ordinal data scale. In this ordinal data scale, it is again a qualitative scale. Only qualities can be kept in this scale. You cannot put any number. It is categorical or quality, where the data can be grouped. You can arrange the data into groups, and important thing is you can arrange them in an order. You can keep them in an order. We will see it. But the intervals between two data within the data set is not equal. Okay, unequal intervals between the categories. We will check with that. We will check that with an example. You will understand more deeply. What are the characters of it? Can you label the data? Yes, you can give a label. Can you arrange in an order? Yes, from small to large, or large to smallest one, you can order. You cannot find the difference? No, you cannot find the difference because there is unequal intervals. If the interval between two data points is equal, then you can find the difference. Otherwise, you cannot find the difference. In ordinal scale, you cannot find the difference as it is not a number. You cannot find the ratio. You cannot find the true zero. These are the characters of the ordinal scale. And what kind of mathematical operations can you perform? Can you perform addition? No. Can you subtract? No. Can you do multiplication? No. Can you divide? No, because these are not numbers. Okay, no arithmetic operation can be performed. Then coming to statistical analysis, you cannot find mean, but you can find median and you can find mode. We will see that with a medical example so that you will understand in depth. Okay, let's define the data set. In the data set, it is actually a clinical trial where 15 patients are taken into the clinical trial and they are given medication for pain killing. At the end of the clinical trial, we will take the pain scale for 15 patients. The data set has 4 outcomes. One is either the patient can be no pain, zero pain, or it can be mild pain, it can be moderate pain, or it can be severe pain at the end of the clinical trial. Imagine there are 15 subjects and this is the data of those 15 subjects. Okay, first patient still have severe pain, second patient mild pain, third patient moderate pain, fourth patient no pain. In this way we have collected the data of 15 patients. This is the data set of 15 patients. Let's check what are all the characters they will have. First one is, can this data be labeled? Can these patients be labeled? Yes, they can be labeled. Patients can be grouped into 4 categories based on the pain at the end of the clinical trial. Few patients can be no pain, few patients are mild pain, few patients moderate, few patients have severe pain. So these can be labeled, these patients can be labeled and these can be grouped. This is the first one. Yes, labeling can be done. Can this be ordered? Can these patients be ordered? Yes, yeah. First is no pain, second one is mild pain, third one is moderate pain, fourth one is severe pain. In this way you can order the patients as well. Okay, that's how you can calculate order. The character or this scale will have the character of ordering. Can you find the difference? Can you find the difference with, can you subtract no pain from mild pain? No, you cannot find the difference. Can you have the ratio mild pain divided by moderate pain? No. Does it have any true zero? No, it doesn't have any true zero. So out of these 5 characters, only 2 characters are possible for ordinal scale. That is, you can label, you can keep them in order. And coming to mathematical operations, what are all the things can you do? You cannot add. You cannot add mild and moderate. You cannot subtract from mild from moderate. You cannot multiply them, you cannot divide them, because these are not numbers. So when there are no numbers you cannot uh, do any arithmetic operation. And coming to statistical operation, what you can do, what you cannot do. Can you find the mean? No, you cannot find the mean. Reason is these are not numbers. How do you find the mean? You have to add everything and divide it by number of entries or number of data points. So that you cannot do. So mean cannot be calculated. To calculate the median, first you have to arrange these in an order from ascending in an ascending order. So these are the 15 values. Out of 15 values, when you arrange them in an order, 8th value is the median. What is the 8th value? 1 2 3 4 5 6 7 8. This is the 8th one. So median for this data set is mild. Okay, you can calculate the median when you have ordinal scale. Next one is mode. Mode can be calculated. Yes, you can see the 1 2 3 4 5. There are 5 nodes and that is the highest. The mode is 5. The mode for this data set is no. The value which occurs most frequently is the mode. In this, no occurred 5 times. That means the clinical trial went on well. 5 patients have 0 pain. Okay, that's the importance of ordinal scale. Next we go to interval scale. How do you define interval scale? Interval scale is a quantitative scale. Till now we have seen quality, now we are coming to quantity. Quantitative, or it is also known as numeric scale. Scale where the data has equal intervals. So that when the patient is in first place, next patient is in 5th place, third patient is in 10th place, the difference between 1 and 5 is same as difference between 1 and 10. So the intervals are true here, and there are equal intervals in between the values, but no true 0 point, no meaningful ratios. When there is no true 0, there are no meaningful ratios. Okay, and what are all the characters of the data when that can be measured in interval scale? Can you label it? Yes, you can give a label for interval scale. You can give a label. Can you order them? It is a numeric, so you can keep them in an order. Can you find the difference? Yes, there are 2 numbers, you can find the difference. But can you calculate the ratio? No, you cannot calculate the ratio because there is no true 0. And when there is no true 0, you cannot calculate the ratio for that. Okay, and there is no true 0. What kind of mathematical operations can you perform on it? Can you add 2 values? Yes. Can you add? Can you subtract 2 values? Yes. Can you subtract? Can you multiply 2 values? You cannot do. Can you divide? No, you cannot divide as well. Coming to the statistical analysis or statistical operations, you can find mean, you can find median, and you can find mode as well for interval scale. Then coming to the medical example, okay, you have to understand this clearly. I have taken a clinical practice example. Think there are 15 beds in a hospital. On 15 beds, there are 15 patients, and you went and checked the temperature of all the 15 patients. We have captured the temperature of 15 patients. First patient temperature is 98.6. Second patient temperature is 99.1. In this way, the last patient temperature on the 15th bed is 98.6 degrees Fahrenheit. Let's check what are all the characters we can have for this data set, where the data set can be measured with interval scale. Okay, first one, can you label the data? Yes, each patient can be labeled with a particular temperature. First patient have particular temperature, second patient have particular temperature, so you are giving a name or you are labeling the patient. Can you order it? Yes, you can order. You can order from lowest temperature to highest temperature. 97.6 degree Fahrenheit is the lowest temperature of the patient, and what is the highest temperature? 102.3. So you can arrange these values in an order, so ordering is possible. Can you find the difference? Yes, you can find the difference. The difference between the temperature of two patients, you can say first patient and second patient. First patient, what is the temperature of the first patient? 99.1 degree Fahrenheit. What is the temperature of the second patient? 98.6 degree Fahrenheit. What is the difference in the temperature? 0.5. So this how in this scale you can find the difference in the temperature. Okay, 98.6 minus 99.1 for these two patients. So in interval scale, what you can do is you can find the difference. The character of difference is present. Can you find the ratio? No, you cannot find the ratio. Even if you find the ratio, it is not valid because the temperature doesn't have true zero. That's the reason you cannot find the ratio, and true zero is not there for temperature. This kind of data set you will not have true zero. Next, coming to mathematical operations and arithmetic operations, what operations you can perform? For addition, first patient and second patient temperature can be added, and when you add it, it is 98.6 plus 99.1 degree Fahrenheit, that is 197.7 degree Fahrenheit. You can add two values in interval scale. Can you subtract two values? Yes, you can subtract two values. 91.1 minus 98.6, that is 0.5. You can find the difference by subtracting it. Can you multiply it? Even though if you multiply, it is not valid. You remember, when the data set falls under interval scale, when you multiply it, it will not have value, and you divide it, it will not have value because it doesn't have a true zero. Okay, that's the reason. Even though if you multiply, it is not valid. Even though if you divide, it is not valid because it doesn't have true zero. And coming to statistical operation, can you find the mean? Yes, you can find the mean. You need to add all of them, divided by 15, it is 99.62. 99.62 is the average or mean of this data set, so you can find the mean. And coming to the median, what is the median? First you have to arrange them in an order from descend to an ascending order. This is the minimum temperature and this is the maximum temperature. This is the first patient and this is the last patient, 15th patient, and as there are 15 entries here, and the 8th entry is the value of median, it is 99.4. Which is the first one? This is the first one, this is the second one, this is the third, this is fourth, this is 5, this is 6, this is 7, this is 8. Okay, what is the median for it? 99.4. So you can calculate median for interval scale. And coming to the mode, which one is frequently repeated? 98.6 is a common temperature. Normal temperature is frequently repeated. It appeared twice, it appeared two times, rest of all the temperatures appeared only once. Mode means which appeared more frequently. 98.6. In this data set, two patients have normal temperature, that is 98.6. Rest of the patients have different temperatures. So in an interval scale, you can find mean, median and mode as well. Coming to the ratio scale, this is the final scale. We will define the ratio scale. Here it is a quantitative data, it is numbers. That's the reason we call numerics. Scale, where the scale have equal intervals. The difference between two data points is equal and they have true zero. Okay, true zero. So allowing meaningful ratios. When the data set has true zeros, when the data has the quality of having true zero, it can have ratios and also it will have meaningful ratios. So what characters this data set will have or ratio data set will have? Can it be labeled? Yes, you can give name to here. Can you order? As it is a number, you can order. Can you find the difference? As there is equal intervals between two data points, you can find the difference. As it have true zero, you can have meaningful ratios. And what mathematical operations? You can add, yes, you can subtract, you can multiply, you can divide. Even though you multiply and divide, these carry weightage, these are valid. And statistical, all mean, median, mode, and also complex statistical analysis or statistical methods can be used on this type of data. Let's go to the medical example. Okay, I have taken a clinical example here. Think that in an hospital there are 15 beds. In 15 beds there are 15 patients, and heart rate per minute is measured. For first patient, heart rate is 72. For second patient, heart rate is 144 per minute. For third patient, again 72. We have 15 patients. You observe here, right? There is one patient with heart rate 0. If you are intelligent, let me know why the heart rate for this patient is 0. Okay, I have seen patients where heart rate is 0. If you have seen, just comment who is that patient. And coming to the characters, can you label each patient? Yes, you can label each patient by the amount of heart rate they have. First patient, what is the first patient heart rate? 72. So first you can label first patient as 72, second patient as 144. So labeling is possible in this type of data, or in this type of scale, ratio scale, labeling is done. Can you order them? Yes, you can keep them in an order. So first patient is 0, from 0 to 144, from min to max you can order it. So ordering is also possible for ratio scale. Can you find the difference? Yes. What is the difference between heart rate of first patient and second patient? 144 minus 72, that is 72. Even the finding the difference is meaningful here because it has true zero. And coming to ratio, can you find the ratio? Yes, the heart rate of second patient is twice that of the first patient. What is the heart rate of second patient? 144. Heart rate of first patient? 72. If you divide 144 by 72, it is 2. The ratio is 2:1. Second patient has the heart rate of twice that of the first patient. Here ratio is also valuable because it has true zero. And what is true zero here? Last patient has 0 heartbeat. There is no heartbeat for him. The patient is dead. That's the reason his heartbeat is 0. That is true zero, completely absent. So in this data set where we calculated, where we are using ratio scale, we'll have true zero, we'll have ratio, difference can be found, it can be arranged in an order, can be labeled. So that is the importance of ratio scale. What kind of mathematical operations you can perform on them? First one is arithmetic. You can add, yes, okay, addition is possible. Add first patient and second patient. 144 plus 72, 216 is the heartbeat of first patient and second patient. Can you subtract? Yes. The second patient, first patient is 72, second patient is 44. When you subtract it, that is 72. You can calculate by subtracting as well. Can you multiply? Yes, you can multiply the heart rate, right? To perform some complex calculations in a system, you can multiply it. When you multiply it, the value is true, it is valid because it has true zero. When you multiply, it is valid. When you divide, it is valid. Okay, when you want to divide the heart rate of first patient with the second patient, it is valid because it has true zero. And coming to statistical analysis, what are all the things can you do? You can find mean, you can find median, and you can find mode. How do you find mean? Add all the heart rates and divided by number of number of entries. Okay, these are all the heart rates divided by 15. The average heart rate is 78.33. And coming to the median, which is the middle value, start from keep the values in an ascending order, start from 0, and highest heart rate is 14. Arrange them in 14. Eighth value is the median. This is the first value, this is the second, third, fourth, fifth, sixth, seventh, eighth. Okay, 78.78 per minute is the value of the median. Okay, this is the median. Coming to mode, which is frequently repeated, 72 beats per minute repeated twice. This is for one patient and There is a second, first patient and third patient have 72 beats per minute. Other thing, for other patients it is unique. Mode means which is frequently repeated. 72 repeated for two patients. That's the reason this becomes mode. And coming to summary, it is very important. I have given it as a table. This is the scale: nominal scale, ordinal scale, interval scale, ratio scale, and this is the character. This is the first character. Can the data be ordered? Can the data be labeled? Can you find the difference? Can you find the ratio? Does it have a true zero? Based on this, you decide to which scale or to which value of measurement this data belongs. If it is a nominal scale, only labeling is possible. You cannot order it, you cannot differentiate it, or you cannot find the difference. There are no meaning, you cannot find the ratio, there is no true zero. When the data comes under ordinal scale, you can label it, you can order it, you cannot find the difference, you cannot find the ratio, there is no true zero. And if the data comes under interval scale, if you have the data and if you want to perform some mathematical and uh, statistical analysis on it, the data is considered under interval scale. If it can be labeled, if it can be ordered, if the difference can be found, but as there is no true zero, you cannot find the ratio as well. And coming to the final scale, ratio scale, you can label it, you can order it, you can find the difference, you can find the ratio, you can find the does it have true zero? Yes. The reason you can find the ratio or you can multiply, you can divide, is because it has true zero. Thank you.